afternoon, good morning, good evening to all our attendees today. I'm really excited to be talking to you guys today about the Semgrep AI Assistant, and in particular about Assistant Memories. Just a little bit about myself. I'm a senior solutions engineer here based out of London. I work with Semgrep's customers across all of EMEA. So that's Europe, Middle East, Africa, and help them in scaling their application security program, sharing best practices, etc. I'm also very active with OWASP here in the London chapter. Prior to Semgrep, I've had 20 years of experience working across different roles. I started my career as a developer, writing C++ code, moved into product, and then solutions engineering for the last 10 or so years. Outside of work, whenever I have free time, I like to spend that with my 5-year-old daughter, or playing squash or boxing. So those are some of the things I do in my free time. And I am a big AI enthusiast. I use it in anger every day. I'm using it for work, for personal stuff. So with that, actually, let's jump into the session today. Most of you might already know who Semgrep is, but in case you don't, Semgrep is an application security platform. We are focused on the build time, and we provide solutions for static analysis, for component analysis, and Citrix detection capabilities. And we have an audacious goal that our founders and the team work towards, which is an audacious mission to improve security, and reliability of software. Yeah. Just a little bit deeper into that. What does that mean? We want to provide you with the tools as an AppSec organization to make it fast, flexible, and easy to customize your application security programs. And a lot of people know Semgrep for the customizable rules, for how fast it is and how flexible it is. As you look at your AppSec programs, you look at static analysis, you look at component analysis, you're looking at secrets. And what we want to do is make it native and integrate into the developer's workflow and deliver on those promises of shift left, right? And at this point, you might be saying, hey, Nathan, I've heard this shift left before, right? Everybody talked about shift left, but it's something where the promises and the benefits have not really panned out. The idea was to surface these issues earlier in the software development lifecycle for your developer, give them guidance, make it easy for them. But what has ended up being is what you see in the picture here. It's a fire hose. It's a barrage of vulnerabilities which you are now hitting your developers with. These tend to be typically unvetted. They tend to be noisy. They waste developer time. They do not have enough remediation or enough specific guidance. And that's the problem. That's the issue that we're trying to break, because what we want to do is have that healthy relationship between AppSec and developers. We want to enable them to give your developers these two things, right? So when you talk to any developer, when you talk to them about shift left, I think the key thing that they're looking at is, hey, can you deliver on 2 key promises? The first one is, you will only tell me things which are real. Only tell me things which are true, real, true positives. And second is, if you show me something, tell me how I can fix it, right? So 2 promises here. One, giving you only true positives, taking into context your business logic, your customization, your business context. And second is, when you show me something which needs to be fixed, give me step-by-step clear guidance, and also make that guidance specific to my business context, to my application stack, etc. Right? So let's look at this in the context of a developer workflow, right? So this is a standard pull request workflow that you're seeing here. And what you see here is really interesting. A developer is actually put in a code. And this is essentially a standard SSRF. I have an input here coming in, HTTP request, and I'm pushing that into my HTTP into a HTTP request here. So I've got this response from the developer, which is user controlled, and I'm now pushing this into HTTP request, standard SSRF. Those of you who use Semgrep already know at this point in the pull request workflow, Semgrep does this. We will essentially run a diff scan very quickly, be able to identify the fact that, hey, by the way, Mr. Developer, you've introduced user input, which is going into a HTTP request, lead to server-side forgery. And by the way, you should use some sort of validation on these input before you push this there. And this is all great, but there is one small problem, which is not just something specific to Semgrep. This is something which happens across different platforms, different SaaS tools, is in our environment, we actually use this homegrown library called validate proxy requests. Now, out of the box, because this is not a standard cleaning for sanitizer like JSoup or Cleaner, no SaaS solution will pick this. But at the same time, the developer is now getting a little bit annoyed because we did not take into account the business context. We did not take into account a knowledge of your software architecture of your stack, right? And for those of you who are familiar with Semgrep, we have a very easy way to solve this. This is using our custom rules. So with Semgrep, we know that the rules are very open, they are trusted, you can see it. And here I can see this rule which flagged is a taint mode rule, which means we are tracking the user input going through different set of functions into a sink. You can see the list of sources and the sinks here, which are collapsed here. So I can always go in and just sanitize this rule, and I can customize this rule and add my own sanitizer here, which will essentially give this. And this is what a lot of you guys do today already in your workflows with Semgrep, and this is great. Very simple solution, takes me like less than 30 seconds. However, what we notice working with customers is you might have cases where you need an additional bit of flexibility. You have cases where your engineering teams have a different set of validators there. There might be different things. There might be additional customization or flexibility. So you have now another library called utility, and in that you have this check safe. A lot of times this is very common in like some Fortune 500 companies, enterprise companies, which are large, which have grown through a variety of code bases, coming in through acquisitions, lots of legacy stuff. And in this case, what would happen is now when the second developer uses this check safe, our rule is going to fail. And we need to now keep iterating on the rule with multiple things. So this is where our team took some of this feedback from our customers and said, hey, how can we make this better? What if we could take the predictability, the formal guarantees, performance which comes with static analysis, but work on one of the challenges we have there, which is the very rigid nature of the rules, and complement it with Gen AI. So if you go back 2 years, our team already started working on this, looking at things in which, hey, how can we take the Gen AI to give us business context, make it context aware, give it a little bit of adaptability, a higher level of reasoning. And even if you go back in history, right, even if you go back 5 years, 10 years, ever since SaaS was introduced, one of the biggest challenges or biggest feature requests you saw from customers was, hey, how do I make my SaaS rules aware of my business context, but do it in a way which is highly scalable, highly adaptable? And so that's where our team started looking at this. And one of the very interesting side notes is, we have our largest team, one of the largest teams in the company is our AI assistant team. It is actually led by our CTO, Drew. So this was so important. We wanted our CTO to actually focus on this. Really, and we tried out a lot of different things. We started off saying, hey, what if we just did not do any static analysis? What if we just did prompting and kept working on the prompting to make it as a replacement for the SaaS engine? And what we found, after a month of experimentation, et cetera, is whatever we tried, we were only able to get to 5 to 10% true positives. Most of it was junk. So in order to make this highly effective, we had to look at a hybrid approach, which is something like this. So what we do is we want a solution which gives you the best of both worlds. We start off with our Pro engine. It's deterministic. It knows, it finds everything. This is what you guys use on a daily basis. We have thousands of customers and tens of thousands of users running millions of scans using the Pro engine. You know it, it's deterministic, it works. And then what we start doing is we start applying filters of AI on this. So the first filter we apply is what is called auto triage, which looks at the finding, it looks at some of the context around the finding and says, hey, as a human, as a junior level triager, do I think this would be a true positive or false positive? Or is it safe to ignore? After that, we go look at AI contextualization. Hey, looking at this specific file or this specific module, what is the importance? Is it a test file? Is it a migration script? Is it a developer script? Hence not an important finding? Or is it something which is impacting the user authentication, which my whole platform is using? And then finally, we provide the fix recommendation. And this is where we give you the actual code with step-by-step instructions to fix it, right? More of a flowchart here. This is what our actual pipeline looks like. And so if you look at these first two columns, the SCM and the scan pipeline, this is what you guys do today already. We have the code here. It triggers a PR. We create a scan. We run the scan either in your GitHub Actions or in the Semgrep Managed Scanning. But the new components are here, which is the Assistant pipeline, where we take the finding, limited amount of code around it, and we use that to actually then prompt the engine to find out those three questions: auto triage, auto context, and auto remediation. And based on this, what we've been able to do is actually deliver on some of those promises. So the first promise I made to you was, hey, I'm going to give you a way in which I can filter out the noise for you and only show you the findings which are relevant. And so one of the capabilities we have introduced here is what we call noise filtering. So this is where the Semgrep scan runs, it finds something in the pull request, but based on the AI and the memories we gave it, you now have the option as an AppSec team to say, hey, should I show this finding to my developers or should I not? Keep in mind, even if you don't show it to the developers, the findings will still show up in the Semgrep UI. So you as the AppSec team are still in control. So there's always a human in the loop. But what you have done is reduced a little bit of that friction, a little bit of that time base that you're getting with kind of the legacy tools where they're getting so much feedback that the developers are saying, stop that fire hose, right? So that's the first thing. We're also now giving findings with step-by-step instructions. So for the ones which we think are true positives, we will actually generate step-by-step instructions in plain English. So even a junior developer can really understand what the issue is. They can see it. Keep this in mind. This is contextual. This is customized to you. This is business relevant. What the legacy tools of SaaS 1.0 were doing was sending you a link to an OWASP white paper with 25 pages of reading. No developer likes that. Or giving you a link to an OWASP training for 6 hours. No developer has that kind of time. So what we're doing here is giving them very, very specific guidance and fix. And what we've seen based on our work with our early customers around this is it saves on average around 30 minutes per fix on average. And keep in mind, we all know, and I started off last year as an AI skeptic. We all know that there might be some hallucinations, etc. But the idea here is how can I get through that backlog quicker? Even if I can reduce the effort needed by 70, 80%, while we still have to review the last 5%, it's still worth having, right? Really, really powerful. And then the third thing that we're doing in that promise is learning from your historical fixes, learning from your context, learning your actual design, learning your software, and based on that, making this. So here, what you can see, really interesting example, I've put in a memory which says, hey, as a standard, we leverage JSoup to sanitize our functions. So very quickly now, every time we run this, every time we generate an AI fix, every time we run triage, we now know the fact that JSoup is our recommended language. And it's really interesting because I gave the instructions in natural language. I did not need to learn any functional programming. I didn't need to learn some query language. I didn't need to do a PhD in how ASTs work. Simple natural language here. So hopefully you can see how we are delivering on those broken promises of SaaS 1.0 in terms of shift left. Today, we're going to focus majority of the section on Assistant Memories. I'm just going to pause here and see if there's any questions in the chat. I see one from Alexi. Hey, Alexi, good to catch up again. Hope all's well. Yes, so when I provide a AI remediation guidance, when you update the PR or you open a PR with the new fix, it will rerun Semgrep on that to make sure that it's being run and it's being scanned and it is actually working as fine. Yeah, so the answer is yes. Any other questions from the team before we jump into now that we understand why memories is important, how we actually do this, and what benefits you get from it? So I'm just going to pause there for 30 seconds, see if there's any questions, either in the questions tab or in the on the chat. All right. So now that we've gone through the kind of the basics here of the what memories are, let's now jump into the next view, which is next section, which is assistant memories. So in this case, I'm going to go over a little bit more detail about how memories work, how you configure them, but also very important topic, what makes a memory good and what makes a memory bad, right? So for those of you who are introduced to AI and LLMs, prompting is really important. So kind of looking at effective ways to prompt or ineffective ways to prompt. The goal for us is really simple. We want to scale our application security program in a way that it has all the context of my business, of my remediation history, so that I can apply that both to my new pull request findings, but also to that backlog where you might have thousands or tens of thousands of findings, to bring all of that knowledge there, right? And so let's look at how to do that in a scalable, secure, and fast, reliable way, right? So now what I'm going to do is look at that same example that we looked at in the previous section where we changed the rule, right? You remember we added that sanitizer called utils.validate proxy request. How would I solve that same problem if I had to do that using AI and Assistant? So let's take that same example. This, by the way, is the view that you would see in the Semgrep UI. Most of you use it, so you can see this. Looking at the same thing there. And what I'm going to do now is, because I did my triage, I know this is a false positive. I'm going to click on the open. And when I click this, I can now click ignore to say it's been ignored. So I'm ignoring this here. And what I can now do is click in the comment, and I can either put the comment there, and I can add a memory here, right? So as soon as I do that, I get this modal here to show you this. And so the first thing you want to understand is the memory or that business context that I am applying. Is that getting applied to just that one specific rule, or is that applicable to all my Python rules, for example, right? Or all my Python SQLi rules. The second thing you also want to do is, am I writing something which is applicable just to that one project, or is it applicable to multiple projects, right? So those are kind of the two things you have to do there in terms of the scoping. The next thing that we then want to do is we want to write a memory. Now, when we write a memory, we want to make it slightly more generic. We don't want to write a memory which is specific to that function utils.proxy validate proxy request. We want to do something which is a little bit more granular, a little bit more broad, right? So here what we want to say is, we could have just said, so we'll say we generally use some sort of validation on user inputs. If the functions are named with some variations of validate, sanitize, clean, etc., that process user input, they mark the findings as a false positive, right? So this is very clear. And then what we can also do is, once we apply this, we now have the option of applying this to existing 43 findings in scope. The scope is based on this and this. So what we've now done is not just made this change once for that one rule or for that one finding. We will now automatically go back in our backlog and apply this to all the valid findings, right? And so this is what I mean by scaling our AppSec program. I don't have to go to per rule, per finding. I can do it in a single click, and literally within 5 minutes, you actually have the new verdicts which will show up in the platform, right? Also in the future, if somebody does anything like this, you can see them actually getting called out. So here you can see, even though we didn't use the function validate proxy request, we use check safe. It is using that same memory to say, oh, I get it. In the previous memory, you told me variations of this. hence I'm going to allow this, right? Still, you have that human in the loop. You have to click here to ignore the finding, otherwise the finding's still there. Also, from an AppSec team perspective, you can still control the finding in the Semgrep UI and reopen it as well, right? So giving you the benefit to your developers of reducing the noise at the same time keeping you in control, right? Really, really powerful. So now that we understand the basics of how memories are used for triage and actually remediation, let's jump into what makes memories good, right? What is a good prompt? What is an effective prompt? What is not? Because at the end of the day, what you're making work with an LLM is to get the results you want. So what makes a prompt effective, right? I get this question, I think 5 times a day saying, hey, how should I talk to the assistant? What should I do? And I usually give people essentially these 3 main points, right? So in terms of when you're thinking about talking to the assistant, think of them as a security intern or a junior security analyst in your team. How would you talk to them? What would you say? How would you make it effective? One is don't be ambiguous. If you give it specific technical details, specific facts, explain the implications of those facts as well. Oh, we are using Databricks. What is the implication of that? Or we are using AWS. What's the implication of that, right? Be verbose. Tell them, be clear, be specific, right? So that's the first thing. The second thing, which is also very important, is what do you want to do with that? As you saw with Semgrep Assistant, there's 3 categories of actions we take, right? There's the remediation guidance we generate, there is the triage actions we take, and the contextualization. So what we also want to do is, if it's valid, make sure we specify, hey, this is very important for a triage recommendation, while this is very important for remediation guidance, or maybe it's both, right? Really important to keep that in mind, to tell the assistant how to use it, right? And then third is, when you structure a memory, I usually follow a rule of 3 here. So first one is, what condition should I be looking for, right? Identify the conditions that the assistant should be looking for in the code base, in the context, in the data flow, right? That's very important. How should you look for them? How do you identify these conditions? And third, what is the implications of these conditions? So it's a bit vague. Let's go into a few examples now to show you how these would be played out, right? These are examples based on real customer deployments. These are real customer deployments. So these are not examples we made up. This is coming from real customer deployments. And what I want to show you is how impactful even writing 2 to 3 memories can be in terms of scaling your program, right? So the first one here comes from a Fortune 100 company we're working with. They're one of the FANG companies. They had a huge backlog of SSRF findings. And when we did the triage, we noticed a few patterns in the false positives. The first one was that they had a lot of static data being used in the URL which was created, that was being pulled for other parts of the code base. Now, Semgrep or any other SaaS tool will not be able to identify that business context very easily. So it made the assumption that it's user controlled, right? So that was one. The second one was, there was a lot of data coming from an internal service, which was defined in another repo. And of course, any SaaS tool would not be able to tell that internal service is not user controlled. Hence, the data coming in is not there. So causing a lot of false positives. Standard issues. I've worked with hundreds of customers who have similar issues. How did we solve it? Literally with 2 memories. So the first one here, let's look at this step by step in that same context of that structure of condition, how to identify the condition and the implication, right? So the first one is the condition here is, SSRF is likely mitigated if the base URL is hard-coded and constant data and configuration is managed securely using the Spring framework, right? So that's my condition. That's my, hey, this is what condition we are looking at, right? And this is what you should assess as an assistant, right? Then to triage, so this is now how to triage SSRF vulnerabilities. Check if the URL are sourced from a secure configuration setting and assess secure handling of sensitive data, right? And then the implication for true positives, the base URL should be manipulated by dynamic data. Really, really simple. Those three conditions, nothing fancy. The second one is even simpler. Here we'd say is data from blah, blah, blah internal services such as blah, blah, blah are trusted sources for data following into the URL. Really, really simple again. But if you step back and think about the impact this had, literally with these two changes, their backlog went from 9% true positive, false positive to 47% false positive. And it's not really a false positive because of the engine, it's a false positive because of the business context they had, right? And being able to identify this, what we've now done is we've increased those true positives by 40% roughly with literally those two things. And you can also see here some of the explanations you're getting here. And when it does give you the explanation, it does tell you exactly what is being used and why it's saying it's a false positive and safe to ignore. So really, really powerful. But the impact here, if you have 1,000 findings and you can reduce 400 of them based on business context, which is tailored to you, how much time did you save? Even if you're spending like 15 minutes on triaging one finding, that's roughly 100 man hours of work that you've saved just because of this. Not rocket science, but really, really makes a significant impact on your efficiency. Second one here is another one which is related to cookies. This was based on some of the work I was doing with another customer, more on the retail side, where they had an interesting one where they were managing the cookies, but when they were doing the management, like deleting the cookies or etc., they were not really setting all the attributes in the cookies in the cookie settings properly. And this was essentially flagging up as a lot of false positives. So what we did here is really simple. We said code which is flagged for missing cookie securities may be a false positive if the purpose of the code is to delete or clear a cookie, as security attributes may not be necessary for immediate removal, right? So if you're clearing or deleting, it's not needed. Really, really powerful. This is where you can see how Semgrep Assistant then ran on their backlog. And again, you can see a 15% improvement there. Really, really powerful. You think about being able to make that impact for your organization, for your developers, for your backlog with literally basic prompting is going to make your efficiency, make your project much less noisy, much more efficient. Before I jump into the common pitfalls, I'm going to pause again for maybe 30 seconds, see if there's any questions from the audience around some of those gold star examples, how it worked. Again, these are not made up examples. This is work based on real customer deployment. So I'm happy to kind of spend more time about it. But I'd encourage you guys to, again, think about having this kind of an impact on your AppSec program in terms of reducing false positives, in terms of making it business context aware. Just going to pause there 30 seconds, see if there's any questions before I jump into the common pitfall section. If there's no questions from the audience, I'd love to ask a question where, just looking at some of these examples, how many in the audience believe this kind of business context would help reduce false positives for them? If you don't mind just typing in a yes or a 1 in the chat, just for us to see. But just curious, how many of you would feel that having this business context would help reduce false positives in your environment today? Getting a few yeses, which is great. Brilliant. All right, so let's keep moving. Let's go to the common pitfalls. So now that we've looked at some of these gold star examples, we know how we should be doing this. I've also seen the other side of it, being in a lot of POVs, including, I know we've kind of worked together on some of these things with a few of the folks whose names I can recognize on the chat. Uh, what we'll do now is maybe look at some examples of memories, and try to see how do we make that better, right? And typically what I've seen with memories, there's like 3 categories of issues which make them a little bit less effective, if I should say. So the first one there is failure to generalize beyond the original findings. So here I see a memory which was factually correct, which is interpolated values do not involve user inputs. That's brilliant. So how do we make this better? So one of the things we need to understand here is, how does the assistant know that it's a user input? It might be great for that specific one finding, but in order to generalize, what does it mean? So interpolated values are program constants and they're not. So making that a little bit more generic there, right, really helps. The second is function is called through a generated method, making it unreachable in this use case. That's great. But how does the LLM know that it's a generated method? So maybe giving something like, hey, a function which is generated from these methods for this framework, X or Y, or these methods looks like Z, are safe. Again, giving it more guidance, specific things like we did there, right? With the functions which start with clean, etc., clean, sanitize, etc., are great. So that's the first one, which is you need to generalize just beyond the original finding to make it more broad-based and make it more business contextual. So this is where your understanding of the organization, etc., will be very helpful. Second is unstated implications. I see this a lot where people will just put in a fact, which is absolutely correct. So for example, the code is located in a QA repository. That's great. It's factually correct. But we don't, the AI assistant needs to understand what the implication is. So we may say something like this is a QA repository. Y class or this class of vulnerabilities are safe to be ignored because of these mitigating factors, right? Because it's this. So we really want to just go beyond the simple fact. The other one I get is really, really interesting. Oh, generate dev secret is used to create development secrets. Oh, brilliant. That's amazing. Again, a fact. What does this mean? So secrets which are then are, so how should I interpret this? Now, what's the implication? This one's really interesting because I've worked with organizations where a dev secret may have the same power as a production secret. And so it's not safe, right? Or I work with cases where dev secrets are generated ephemerally, destroyed ephemerally, and have no production access. Great. So we need to tell the assistant, hey, what does that mean? And the last one is, Dockerfile uses an image which is designed to run server as a non-root server. I see this a lot with our Dockerfile rules. Really interesting. Again, very great. What's the implication? What we want to do is this an implication? Is this acceptable risk? Is it, if there's a specific image, if there's a specific Docker file being used, we need to be specific in that. So here we can say, hey, this image is there. So this is the second category, which is unstated implications, which is lots of facts, but very, very tough. It doesn't understand, the AI doesn't understand what to do with it, right? Again, that structure of condition, how to identify the condition, and the third one is what is the implication? Very important, right? This is my favorite one. This is amazing because it is actually important to understand what is the LLM context, right? So when the Semgrep Assistant analyzes a finding, what we will do is we will send certain data as context. So the first one is we will send the lines of code, certain number of lines in code above and below the specific finding to the LLM. We will send the data flow, so complete data flow. So if your function user input comes in through, for example, Flask, goes through a bunch of functions and then goes to my Python ORM, I'm going to send that full data flow there. Certain number of lines of code above and below. So we never share the full code to the LLM. We only share specific code snippets. We will send the rule. We will send your triage history. We will send our knowledge base. There's a lot of work that my security research team has done in terms of that training, etc. That goes in. Prior fixes will go in there, right? Now let's look at what information we do not provide. Please provide an alternate solution. We don't actually send the solution back there. So, and we don't know which alternate solution are you talking about. So what we need to do in this case is, if in the alternate solution we recommended, hey, use library X. So I said use JSoup, but you use utils.clean. Say, hey, do not use this instead, right? So that's very important to say alternative validation library. This one's my favorite. Please refer to a URL. We do not have access to URL. So what you would do in this case is actually just copy paste whatever the relevant parts of that URL is there into the memory. Third one is API keys from fork repos pose no risk to the company. And very interesting. Couple of things here. One is no SaaS solution actually has the ability to know if the repo is forked or not. It's very, very tough to tell programmatically if it's a forked repo or not. Second is, at some level, every repo is in effect a version of a forked repo, right? So it's not very meaningful. Instead, what you would do here is be more specific in terms of, hey, these are the repos or these are the tags which are actually associated with these repos, hence don't run this, right? Again, really, really powerful way in which you can actually make that there. So common pitfalls. So if there's anything you want to take away from this in terms of this section, three things. Generalize beyond original finding, be very clear and state your implications clearly. And then third is understanding the context, what is actually being sent and what is not being sent. I'm just going to pause there, see if there's any questions on this. Otherwise, after this, what we're going to do is maybe make it a little bit more interactive and maybe do a group exercise. Where what I'll do is I'll show you some examples of memories, and we as a team together work on how do we make them better? What can we do differently? Yeah. Is everybody up for that? All right. So let's start with the first one. Let's try to improve this one. So this is a memory which is there. The generated SQL does not work with Databricks. How would we fix this? I'll give you guys 30 seconds. Any ideas? Feel free to type those in the chat here. That's a great suggestion, Alexi. Exactly, that's really good. So what Alexi said is really interesting. So again, going back to the pitfall number 3, we do not know what that generated context is. We do not know what was previously generated and shown to you. So you have to be specific about that part. What jumped out, what did not work, which commands did not work, which Databricks, what was the problem there, right? So that's one thing we have to look at. Any other thoughts? Great job, Alexi, on that one. So the second thing is we need to generalize beyond just one finding. So this SQL statement with Databricks is an issue. Are there other issues which are out compatibility with Databricks? So maybe we can improve this by saying something like, when generating remediation for such issues, ensure the SQL is compatible with Databricks, right? So giving that prompt to say, hey, you have to think about Databricks. So a couple of things. One, exactly which specific commands, what was the problem last time? And second is the compatibility, right? So good job. This one's again an interesting one. Example 2. Lack of entropy in a detected secret likely indicates a false positive. Any takers? Jackie, from next time, I think we should have like some sort of prizes to get people excited about this. Any thoughts on this? What's wrong with this one? What kind of issues are there with this one? Lack of entropy in a detected secret indicates a false positive. I see Alexi is typing, so I'll give him 30 seconds and then otherwise I'll jump in. That is correct. So here is, we gave it a condition, which is lack of entropy, but we didn't tell it how to measure it, how to identify. Now, one of the things we need to understand is LLMs, independent of Semgrep or not, are not capable of things like entropy analysis. They can't do entropy verification, etc. So in this case, what we'd have to do is give it additional prompting, just like you said. So give it other ways in which can identify weak secrets. So secrets like my test password or secrets which are made up of known words or known nouns are inaccurate, right? Are false positives. So really, really powerful way. Good job, Alexei. This one's really interesting. Let's look at this last one here, which is, which is the function argument is a static string created with create path function whose parameter is also a static string, ensuring no input can be can modify the exit thread call. What's wrong with this one? How can we improve this? 30 seconds. There's no wrong answers, guys. Don't be shy. All right, I'll take a stab at this one. This is very, very specific. And one of the things we want to do when we write memories is to make them more generic. So here, there's a very specific create path function, exit thread call. We could have done that by just creating a new rule if we wanted to. So make it more generic, make it more less specific, right? So those would be the things. So that's great. I wanted to spend maybe 5 minutes on what's coming next. We talked a little bit about Semgrep AI Assistant. Hopefully you saw the value in the assistant, how it can help reduce your false positives, how it can help give remediation guidance, also with memories, how we can now tailor this to your business context. Some of the other things we're doing here now is actually starting to look at ways in which we can use assistant for things like rule writing. So you've already seen that in the Semgrep editor, where you have the option to write AI-based rules. But the whole idea here is we want to create like an AppSec on autopilot kind of a program for you guys to help reduce the amount of time which is taken for mundane tasks. How can we give you efficiencies there from a triaging perspective, from a remediation perspective, so you guys can focus on getting the real work done in terms of getting fixes, getting things done, etc. Right? So really, really powerful. I'm just going to pause there. That's the end of the presentation.